Good evening, everyone. Hello. I'm Balaji Rathakrishnan. I'm a group program manager in the SQL Server team at Microsoft. As you might have heard from various sessions at the PDC so far, programmability is a big theme in the Yukon release of SQL Server. We are enhancing significantly various dimensions of programmability inside the SQL Server engine. You might have heard about the support for .NET framework inside SQL Server, which enables programming SQL Server with various managed languages. You might have also heard about XML support, deep support for web services, and so on. So you might be wondering, so what is happening to good old Transact SQL? And I hope this session can answer that question. I would like to assure you that Transact SQL remains the best and in fact only data access language that SQL Server supports. And many of these various enhancements that we talk about in terms of support for managed languages, XML, and so on, they all get used through SQL, Transact SQL in a way, and in a way complement each other as opposed to replacing the programming paradigm here with Transact SQL. So let's get right to it. Let's look at the various enhancements that we are doing in the Transact SQL space in the Yukon release. I have structured my talk in terms of three broad aspects of Transact SQL. First is the query language, which is probably the most important part of the language. We also have the procedural language. So the query language essentially involves extensions to select statements, insert, update, and delete, which enables you to do more in a single statement so that you don't really have to use procedural statements in order to do what you want. And you are taking advantage of the query processor by doing that. And then I'll talk about data types, the new data types. That's again, this list of data types that are supported is an inherent part of any programming language, and Transact SQL is no exception to that. And then finally, I'll talk about the procedural enhancements, which is to do with control flow, logic, and so on. So these are the various broad enhancements to the query language we are making. I'll go through each one of them. So the first one is what we call as common table expressions. That's the actual official name of the feature. It's also popularly known as recursive queries. So this feature basically enables you to access and traverse recursive hierarchies in a single table. So this is a very common pattern that we see in applications where you represent a hierarchy in a single table. And this is not a flat, fixed level hierarchy. It's a recursive hierarchy in the sense that, let's say you represent an organizational reporting hierarchy in your table where you have a manager ID and employee ID that has a self-referencing referential integrity constraint. Another example is, let's say you have a bill of materials table where you have a set of parts that define a set of subparts, and so on and so forth. So when you have such a table, today if you want to write a query that says, given this employee, show me all the employees who report directly or indirectly to their employee, it's not straightforward. You have to write that through procedural logic, use temp tables, and build that yourself in a stored procedure. The same thing with the parts scenario as well. The common table expressions feature lets you do that much more easily using a single statement, a single select statement. So this is based on the SQL 99 standard, where we have what we call a common table expression that gets defined before the statement. So the general form of this statement looks like this. So you have a with CTE name, which defines the name of the common table expression, and you define the list of columns that are produced by that common table expression, and then you define that CTE. The CTE definition is basically a select statement. I'll talk more about that in subsequent slides. And then you have a select statement that uses that CTE. So one way to think of this is like an inline view definition. So instead of a view that I persist in the database and use it multiple times, in this case, I'm defining the CTE right inside that select statement. And then I use that CTE in my select statement. So this by itself doesn't say anything about recursive queries. So this is a generic feature that you can use even non-recursively. So it has both recursive and non-recursive forms. I'll just briefly mention the non-recursive aspect of this feature. So often you may have your queries that do a lot of derived tables, where you have your from class that defines another select statement that's embedded inside that from class, and you may even have that multiple levels deep, and you may have multiple of those in the same select statement. This allows you to rewrite that in a more structured fashion, where you define, especially if you're using the same subselect or a derived table multiple times in your query, you get to define that once as the CTE and then use it, reference it multiple times in your query. Now let's talk about the more interesting use of this feature, and that is when the CTE itself is recursive. So the recursive form of the CTE cannot be a very arbitrary form. It has to be following a very specific format. So it's basically in the form of a union all statement. So you have a non-recursive select statement followed by a select statement that references the CTE, which is the recursive arm of that select statement. So the recursion here works a little differently from what you may be used to in traditional programming languages. So the first select statement initializes your result set. The second select statement accumulates on top of that. The recursion stops. So basically, you build an initial result set and you union that result set, because you're referencing that recursively, with your second select statement, and you keep going until the second statement, the second select, produces empty results. So let's see some examples. This, by the way, is how you might typically do this without recursive queries. It's deliberately not readable. So I didn't. Just to give you a flavor of how it looks today. And this is how it looks with recursive queries. Thank you. So I defined, so the example I chose was with the employee hierarchy example. So I have my first select that fills the first level. So let's say I find all the employees that report directly to or indirectly to the employee whose employee ID is 1, 2, 3, 4, 5. So my first select statement here builds the initial result set. And then the name of the CTE here is mCTE, and it has a list of column names, just like a view definition. And then I use that recursively in my second select statement. I use that to build the next level. So I do this join, again going back to my employees table, joining with what I have produced so far, and I'm joining based on this join ID. So that's pretty much recursive queries in a nutshell. Let's move right along to the next feature that I want to talk about. Ranking functions. So often you may have a need for ranking data values in your table. So you don't want to just order the results in your table, order the values in your table, but you also want to rank, generate rank values based on that ordering. So you may have sales data, so you may want to rank products based on how much sales that they are generating and assign rank values to each of those sales data. So we have different flavors of these ranking functions. So there is rank and then dense rank, and entile is another flavor of rank, if you can think of it that way. I will not go into the exact definitions of these functions right here, but I will illustrate them using a demo later. There is another function called row number, which doesn't really rely on ordering of data values, but it just numbers rows. Thanks. So all of these are again based on the SQL 99 OLAP extensions. So you basically are able to use this ranking function, and the syntax looks the way it is here, where I have a partition by class and an order by class. The partition by class lets you partition the data that you are working with based on a particular column, so that you can generate rank values within each partition. You may not want to have a full ranking through all your data. You may want to partition your data into multiple partitions and generate ranking within each of those partitions. You don't have to use that. If you basically skip that partition by class, then you are basically, you have one partition by default, and you're generating rank values through that single partition. And then you specify what column you want to order by as well. So the scenarios that this is useful for are fairly obvious. So you want to do some data analysis for OLAP kind of applications or reporting applications, where you want to generate rank information based on data that you have in your tables. So the interesting scenarios here are the ability to generate ranks based on different criteria in the same query. So as you saw in the syntax, you have this localized or a locally scoped order by. Instead of having this order by at the very end of the table, very end of the select statement that controls the presentation order, whereas this order by is used just locally to generate those rank values. And what is the benefit of that? You basically can generate ranks based on different criteria in the same query. You don't have to have separate select statements with different order bys and so on. You're also able to separate the presentation order from the rank values that you generate. You may want to display the data in a particular order, but then you may assign rank values based on a different order. Again, this locally scoped order by lets you do that. Row number is more interesting from a paging perspective. So you have, let's say you have a search page where you're paging through result sets, and in your web page you are presenting results one page at a time, and you want to be able to page through these result sets. This is obviously a very common design pattern, and the row number function makes it easy in certain cases to enable that scenario. So I will go through some of those scenarios using a demo. Let me first show this sample, which highlights the first benefit that I just talked about, where you're able to rank products in your product sales table based on different criteria in the same query. So you're generating rank values by using an over order by clause on unit sales, based on revenue that's generated, and maybe based on unit profit as well. Hopefully I can illustrate some of that using the examples. So let's look at some of the example scenarios. So the first scenario primarily shows the usage of ranking functions. So let's say I have this race results table where I have results coming in from different races in an event, let's say. So I have a race ID column that identifies the race itself, the name of the athlete, this is the lap time that athlete did in that given race, and then I just have entered some sample data. I have two races here for some athletes with their race times. So let's go make sure we are in the right database. So this is the query that I would like to show. So here I am generating rank, dense rank, and then entile over 3. I'll go over each one of those right now. So rank generates rank values partitioned by race ID. So it's meaningless to do ranking across races, so I'm doing a partition by race ID and generating ranks for each of those races. I am also generating dense rank. The distinction between these three will become clear in a moment. So that's the results I get from this query. I'm sorry, what did you want to see? Oh, yeah. So as you can see, I have results for these two different races. I have the rank values. So as you can see, the values are here. I intentionally projected the time values so that you can see the correlation between those and the rank values. And the difference between the rank and dense rank here is that how they treat ties or distinct values. As you can see, there are two ties here for the rank 2. Both these athletes have 10.5. And then Steve, who had a 10.6 timing, is ranked 4 because there are 3 athletes ahead of him. Whereas dense rank does not only counts the number of distinct values ahead of that value. So Steve now gets rank 3. So that's the main difference. Entile 3 essentially groups these values into buckets. And you get to specify the number of buckets in the argument of the entile function. So clearly, if you specified 100 as the argument of entile, you get percentile. So entile is a generalized function where you can assign it into any number of buckets that you choose. And the way it fills these buckets basically tries to evenly distribute the buckets. And you might see at most a difference of 1 in how the buckets are filled. And also, the overflows are filled from the first bucket. So you'll see these additional values in the first bucket. So that's ranking functions which can, again, with these various flavors and also using different arguments of the entile function, you can solve many of the data analysis needs in terms of generating ranks based on these values. So entile basically assigns buckets to each of these values. So it orders them based on that order by criteria. And then it assigns them to n buckets, each with equal number of values. No. It just, so if you are sorting 6 values and you're dividing it into 3 groups, if you used entile 3, in this case you would have seen 2 per bucket. In this case, since there are 5 values, you're seeing non-uniform size buckets. Okay, let's move right along. I almost forgot. I have another demo. So this is the this is using the row number function. So this is just a very simple web page where I am searching my data in the database. So I'm looking for products of a given color, let's say red. And there's nothing fantastic about this. This is a regular search page, but something which is very common to all kinds of searches, where I have previous and next, and I am paging through the result set. In this case, I happen to sort the result set based on the name of the product. So you may notice that the products are appearing in alphabetical order. So that by itself is not that interesting. Let's look at the code behind it, which is probably more interesting. So this being the PDC, I had to find a way to show C# code. So here it is. So I'm not going to go into the various aspects that generate the web page here. I'm going to focus on just the data access portion. So the get search results method is doing the bulk of the work, where it gets a search criteria and a page number, and it's basically generating the starting position and the ending position of a given page. So I'm given the page number and the page size, I am determining the first row I want to show and the last row I want to show. Once I have that, I am actually using another feature that we talked about today, which is the common table expressions. But I'm also using the row number function here. So I'm basically generating row number. In this case, I'm ordering by product name. And I just use that as my common table expression. And then finally, I filter, which is the key thing here, which filters the rank between the from and to values that I just generated. So I could have easily written this in the form of a derived table where I have a single select statement where inside this from clause I could have embedded this common table expression. I just chose to showcase both these new features together, which is the non-recursive form, which is just happens to be more readable. Now, one question you might have at this point is, why did I not do this filter right inside, or using just a single select statement where I generate the row number and I use the between predicate in my where class right there? The reason for that is to do with the order of evaluation. The row number function, so the traditional SQL semantic states the from clause gets evaluated first, semantically speaking. I mean, the QP may not do it that way, but semantically it generates a result set from the from clause, filters them using the where clause, and for those qualifying rows evaluates the set of expressions in the select statement. So in this case, the row number function is getting evaluated right there. So I cannot use it in the same where clause. Just the visibility rules dictate that it can be only used in a outer select that consumes that row number function. So that's basically showcasing the row number function. Can we hold questions to the very end? Thank you. Okay, so moving right along, let's talk about some new relational operators. So you're familiar with the existing relational operators, joins, outer joins, unions, and so on, that take two relational inputs and produce a relational output. So these are three new relational operators that we have introduced in the Yukon release. Pivot. Pivot is a common scenario that you use in Excel when you have some data that you want to transpose from a row format to a column format. I don't know how many of you are familiar with the transform statement in Access. A few. That does exactly the same thing, except we chose to expose this not as a separate statement, but more as a relational operator, so that you can compose it with other relational operators like joins and outer joins and so on. It's useful for what I call open schemas and OLAP scenarios. I'll showcase the open schema example in a subsequent slide. Unpivot is pretty much the reverse operation of pivot. So basically, you take a wide format where you have a set of columns that you want to transpose back into a set of rows. Unpivot lets you do that. Apply. Apply is a new operator which allows you to evaluate. So it has two table inputs. So you can think of them as left input and a right input. And the right input in this case can be a function of the left input. So a very typical example, in fact that's the only example where apply is extremely useful, is let's say your right input is a table valued function. So you might be familiar with table valued functions that we introduced in SQL 2000, and we are enhancing them in Yukon with the ability to create table valued functions in managed code. But in SQL 2000, you might have noticed the restriction that you cannot execute a table valued function which takes a column as an input, a column that came from another table in the same query, which requires you to evaluate the table valued function multiple times. In fact, somebody asked this question yesterday at the end of the talk on the managed support in Yukon. Now, cross apply, the apply operator relaxes that restriction by basically you can now call the table valued function for every row from your left input. So you can say table T cross apply table valued function that takes an argument which is a column from the table T. So what I do is for every row of that table T, I evaluate the table valued function given that column as an argument, and I produce set of rows for every invocation. and then I do a union across all of them. I didn't have samples of that here. The reason I elaborated on that right now is because of somebody's interest yesterday in the presentation. There are two flavors of this. There is the cross apply and the outer apply, similar to cross join and outer join. In the outer apply case, if the table valued function produces no rows, it produces an empty result set, then you will not lose the row from your left input. You will still produce a left input row and fill in null values for the values from the table valued function. Okay, so pivot. So I'll show a scenario where how you can use pivot in conjunction with what I call an open schema. So in this case, you have a schema where you are storing attributes of an object using name value pairs. So you have an object ID column that identifies the object, and then you have the name of the property and then the value of the property. Presumably you may be using SQL variant as the data type of this column. Now, given this format, let's say you want to generate a result set that looks like this, where I have columns for every property that I'm interested in. So I have a separate column for the name property and a separate column for the author property. Now, the query that you would write to generate this result set is as follows. So you have the pivot operator has two specialized columns here, the prop val and the prop name. This is what I would call as the value column, which is what you are filling the result set with. And prop name is the pivot column, which is what you are generating columns out of. And then you specify the actual values of those properties that you want to generate as columns. You're also required to do an aggregation of that, but in many cases, for example, in the open schema case, you're already guaranteed to have one value per object ID and property name combination. But then the min here is a no-op, it just generates that one value. But you could also have in more of a, let's say you have sales data, monthly sales data that you have for a given product, and you want to generate a report where you have a column for each month. So again, that's another scenario where you would use pivot to go from a row representation to a column-based representation. This is a very common design pattern that people do today, and they generate a lot of dynamic SQL to do this, and this is something that makes it a lot easier. Okay, so the next feature I'm going to talk about is the DML with outputs. So today, when you execute an update or a delete statement, all you get back is just information as to the number of rows that were affected by that statement. The new feature here is the addition of the output class in a DML statement. What this allows you to do is, as part of the update in a same atomic operation, get back values that were updated by that update statement or the delete statement. Again, this is a common need where people want to do an atomic round trip where they go update a table and then get values from the table. A common scenario is actually a dequeue operation. I don't know how many of you implement queues inside a table. When you dequeue or remove an element from that queue, from that table, what you might want to do is remove something from the queue, but at the same time return that as a result set so that you can use that in your client. So the inserted and deleted columns, so you are familiar with the inserted and deleted virtual tables inside a trigger, which capture the pre and post values of the DML operation. So you can use those columns, the columns from those virtual tables, in your output class to get those values. You can also store the returned rows into another table using the output into class. So this is the example. So let's say this is a regular update that you have today, and what we have now is the ability to specify an output class. In this case, I am outputting all the new values and the old values. from the inserted and deleted tables. This output class looks very much like a select list, where the list of columns that I have available to use in that output class are the inserted and deleted table columns. I could just have output only the inserted values if I am interested only in the new values, or I could even specify only a subset of the columns in my inserted and deleted tables. Okay, how many of you have used full text search in SQL Server? Very good. I'm sure you will appreciate many of the enhancements that are happening in the space. So in case you're not familiar with full text search in SQL, full text is a powerful functionality to efficiently search non-structured textual data in your varchar or var binary columns. You enable that by creating full text indexes on your string or binary data types. And we use the MS search engine, which is the Microsoft full text search technology, to create indexes based on these data types, which then facilitate search predicates using predicates such as the contains predicate, where you can search for, say, various keywords in your full text column. So this is an existing feature. There is nothing new here in Yukon in terms of the functionality I show in this particular query. What is enhanced in Yukon is a significant improvement in both the scalability and the performance of both the process of building the index and also the performance of these full text queries. So often, since index building is a very important step, which in SQL 2000 is more bolted on the side as opposed to integrated completely with the database engine. Whereas in Yukon, it's much more integrated with the database engine, and it has resulted in a significant performance improvement, especially in the index building scenario. So we have at least an order of magnitude performance improvement for the index building process itself. The query performance itself is also better by up to 30 to 50%. In terms of functionality, there are a whole bunch of new features that full text search supports. We now have thesaurus support, which enables you to not just look for the terms that you specified in your predicate, but also synonyms of the terms that you specified. You can also now do full text searches against multiple columns in the same query. So you used to have a separate predicate on each column, and that actually essentially meant that we had to go and look at multiple indexes and join them together. But now you're able to actually look at multiple columns in a single step. We also have improved language support. So this is an interesting scenario if you have multilingual data in the same column. So typically you would configure the language for a given full text indexed column, and that's the default language that will be used when you're searching against that column. But what happens if you have multilingual data? You may have Word documents that contain multiple languages, and your default may not work. In that case, we allow you to now specify the language that you want to use for that specific query, so that you can override the default that is specified for that column. We also have configurable accent sensitivity and insensitivity. We also have enhanced support for distributed queries. So with SQL 2000, the full text predicates could be used against a local table, but if you had a linked server that is pointing to another SQL server, and if that SQL server had full text indexed columns, you will not be able to issue contains predicates against that linked server. With Yukon, that restriction is removed. Now you have distributed query support for full text predicates as well. We also now have support for full text searches over views as long as they are indexed. So we already have the indexed view mechanism that we introduced in SQL 2000, and if you create an index on the view, you will now be able to issue full text search predicates against that view itself. Manageability. Even more than the scalability and performance benefits, this is probably the most significant improvement. Today in SQL 2000, you have to, as I mentioned, the full text indexes they have this feel of being bolted on the side from the database. They're not really managed in integration with the database. They're not backed up and restored along with the database. So that is addressed in the Yukon release. Now you have fully integrated backup and restore. The catalogs also participate in the recovery process when we recover a database. This also means that you have better transportability of the full text catalogs along with your database. Say you're moving a database from one machine to the other. In that case, the full text catalogs travel with you when you take the database from one machine to the other. The other manageability benefits, instance level resources. So if you have multiple instances of SQL Server running on the same machine, previously in SQL 2000, they all share the same instance of MS Search. So any configuration changes you made to that single instance of MS Search affected all your instances. Now we have separate configuration for each of those instances of Yukon on that machine. And finally, from a security context perspective, MS Search is now more integrated with SQL Server in terms of the security context under which it runs. So today, MS Search always runs under the local system account in SQL 2000. With Yukon, it will run under the same security context as the SQL Server service itself. Okay, so that concludes the query language portion of my talk, where all these enhancements that are happening within the query language that enables you to do more in a single statement. It's more expressive, more concise, and you are taking advantage of the full power of the query processor. Let's now move on to richer data types. So what are the data types that we are supporting in the Yukon release? I'll talk about XML, of course, and I'll also talk about varchar max, nvarchar max, and var binary max. XML. So I'm not going to go into great detail here about XML. The reason being there is a completely self-contained talk talking about XML tomorrow. That's D8402. So I would refer you to that talk for more details. Here I'm just going to give you a very quick overview and also talk a little bit about the orthogonality aspects of XML, where you how it fits in the T-SQL language framework, how you can use XML as a first-class data type in T-SQL. So the scenarios, I'm sure you're familiar with the XML scenarios. XML is great for platform-independent data/message transport. It enables both data and application integration. Further, it also enables you to store semi-structured data, where you may have some structure defined, but also have some unstructured data in your XML documents. Now, in SQL 2000, we already had great support for XML. We had the ability to map from XML into a relational table structure back and forth. You could go from an XML document, shred it into a relational table structure, and vice versa. You could generate relational result sets using a select statement and then use the for XML class to generate XML from that result set. In Yukon, we are taking that support one step further, and we are supporting XML very deeply as a native data type inside SQL Server. So it's a first-class data type in Transact SQL, which means that you can use it as the data type of a column in a table so that you can store XML data as such in your relational tables. You can have variables and parameters of type XML, which means that you can pass XML around through various stored procedures, functions, and so on. You can also have constraints placed on your XML data using XML schema. So when you create tables with columns of that type XML, you can also specify a constraint that says, I want these XML values to be valid with respect to a given XML schema. We also support data manipulation on that XML value, where we support searching that XML values through XQuery, XPath, and a subset of the XQuery standard. We also support DML, modifications to those XML values, partial DML. We also have interoperability between XML and SQL. So within your XQuery, you can actually reference relational columns and T-SQL variables by embedding them using a specific syntax in your XQuery statements. So I have a very quick example here where I have a candidates table, and it has two columns. I have an ID and a resume. In this case, the resume is of type XML. And I have an example that shows an XQuery against that resume column. This : syntax may be reminiscent of how you invoke methods in a user-defined type. So this is the same paradigm. So XML looks and behaves like an abstract data type with behaviors. So you are essentially calling the query method from that XML column. And then the string that's inside that query method is the actual XQuery. So this is another case where I want to stress that you are really using this new paradigm, which is XQuery, but you're using it in conjunction with T-SQL. Again, I won't go into any more detail, and I'll ask you to attend the session tomorrow if you're interested in more details. Varchar max. Although I titled this Varchar max, it really includes varchar, nvarchar, and var binary. So I'm sure you're familiar with the lob data type support in SQL, text, and image. One of the issues with these data types is that they have a completely separate programming model from their small counterparts, the varchar under 8,000 or nvarchar under 8,000. So varchar max is basically taking a big step towards unifying the programming model between these two models, both the small values and the large values. So we came up with basically you use the same data types, varchar, nvarchar, and var binary, except you now specify, instead of having a very specific size as the max size, you specify this keyword max, which essentially means that you can go up to 2 gig as the size limit for these data types. One key thing here, though, is that they don't support text pointers and the various statements that take text pointers as arguments. Just the way varchar and nvarchar don't support text pointers, these data types will not either. So as I mentioned earlier, varchar max brings together the programming model of small and large values. Today, I'm sure you run into various limitations when you try to use text, image, and text values in your applications. For example, if you look at triggers, the inserted and deleted tables don't really reflect text and image values, especially the new values of text and image values. They are not comparable. You cannot compare two values of that data type. Concatenation, built-ins, any of the built-ins that work with string values or binary values like substring. Actually, I think substring does work with text, but things like replace, concatenation, none of them work with n-text values. Aggregate functions that work with varchar, small varchar values do not today work with n-text, but they will now work with varchar max. You cannot have variables of type text, n-text, and image. Now you can have variables of varchar max, nvarchar max, and var binary max. So the biggest scenario here is, of course, to facilitate a smooth transition when you have small data that might outgrow the 8K limit. Or you may have the scenario where most of your data is really small, but then you have some outliers that are greater than 8K, and you are forced to now use the n-text or text image data type, and take a significant hit in the programming model and the amount of functionality that you get. Now, by introducing all this rich functionality on the varchar max data types, you don't have that issue. So this is not just about functionality, but also from a performance perspective, they do use the in-row blob infrastructure that was introduced in SQL 2000, which means that if your varchar max values are indeed small, and if they can be made to fit in a single page, then they will be stored in row in the same page. And only for those values that don't fit in that page will be stored in a separate B tree, so that you're not really paying a performance penalty for small values. So as I mentioned, all string functions operate on varchar max. We already have a way to read chunks of data from your lob data type, which is substring. So today you do read text on the read text statement on text and image data types to extract chunks from it. Now you will use just the substring statement in your select statements. The update statement now has been enhanced to support chunked update. So you can specify a new chunk to be updated in a given offset, and also remove a particular chunk. So this is basically mimicking the functionality that's today available through the update text statement. Now it's integrated with the update statement, so it's not a separate statement. It doesn't have some of the problems with update text. It is logged as a regular update, and so on. Okay, so that concludes the data type section of the session. Let's move on to procedural transact SQL and see some of the enhancements that we are doing in this area. DDL triggers. So today you're familiar with triggers that you can create on DML operations, like when you're inserting, updating, or deleting data in a table. So you can think of DDL triggers as triggers on updates to metadata as opposed to data. So whenever you are executing DDL statements, now we now allow you to create triggers for those DDL statements. So the triggering events include pretty much all the DDL statements that we have. So you can create a trigger that fires for all create tables or for all alter procedures. And you can actually create the same trigger that will fire for multiple of these events. Just the same way you can specify a DML trigger for multiple DML events like insert, update, and delete. Also, what is the scope of these things? Do I want to fire a trigger for every DDL that happens in my database server? Or do I want to scope it to the database level? So we support both those different scopes. So you can have triggers that are defined at a server scope, and also triggers that are scoped at the database scope. And then, of course, triggers are not useful at all without, inside the body of a trigger, having some way to get at what really happened which fired the trigger. So in the case of DML triggers, you have these inserted and deleted tables that tell you what rows changed and what the new and old values were. In the case of DDL triggers, we have this new built-in function called event data that gives you all that information. Okay, so you have this great feature. So how can you use it? There are a whole bunch of scenarios that we think DDL triggers are useful for. One is enforcement of development rules or standards for objects in a database. So when somebody comes and creates a procedure or a table, you may want to enforce some design rules. You may want to use some naming conventions. So you could check all that in the trigger. And of course, the most interesting thing there is that you are able to deny the DDL by doing a rollback inside the trigger. So just like you can roll back, you can issue a rollback inside a DML trigger, which rolls back the changes that happen to the data. You can essentially fail that DDL by doing a rollback inside that trigger. Other scenarios are protecting from accidental drops. That may be a useful scenario. Also, you may want to implement your own source versioning or source control mechanism for your stored procedures and functions inside the database. I have a demo that shows that scenario in action. You could also log management activity. Let's say you want to record all DDL that's happening in the system and stash it away on a table that shows what DDL happened on the database. Incidentally, SQL Server replication takes advantage of DDL triggers in a big way. So today, they don't have great support for DDL replication as they do for DML replication, that is data replication. With DDL triggers, they are able to capture DDL actions that are happening in a publisher and replicate those things on the subscriber as well. So one of the additional benefits you get from this feature is enhanced support for DDL replication itself. Okay, so let's look at the scenario where I just built a couple of DDL triggers that enforce certain rules which basically implement a check-in, check-out based mechanism for modifying objects in the database. So let me first show how this works, basically testing those DDL triggers, and then I'll show the DDL trigger itself. So let's go to the right database. And in this case, I'm going to actually mimic two users working with this table called foo. And I don't want to go back and forth between these two users, so I'm going to use the set user statement to mimic the logins of those two users. Basically, set user lets me go from my default security context to a different user if I am the DBO. So by default, I'm logged in as DBO. And DBO now tries to alter the table. So I have a DDL trigger for the alter table statement. And it just said I cannot do this alter because I haven't checked the object out. So let's say before DBO gets a chance to check it out, let's say that user Bob came in, and I show that by basically doing a set user to Bob, and they check it out. So the checkout is really implemented through a table where you record who has currently checked it out. So it's basically a table where I have a unique key established on a given user and the object name. So you cannot have multiple users checking out the same object. Now let's say I go back to DBO, and DBO again tries to check that modify the table. And again it fails because it says user Bob has that object checked out. This is basically a message coming out of my DDL trigger. So let me go back to being Bob, and now Bob, having checked it out, can actually go modify that table. And then once Bob has finished his work, he does a delete from the checkouts table. So he's using where user equals current user. So basically he's removing the row corresponding to himself. Now DBO comes back and then checks it out. So in this case, they are now able to go and do the alter, and now the alter succeeds. So another interesting thing here I've done is using another DDL trigger, I've also recorded the multiple versions of that object that existed at various points as all these triggers happened. So whenever I fire these trigger, I record what change that happened and put it in a separate table. So in this case, I have the object versions table where I show the time it happened, the user who made that action, the action itself. So there is a drop table, create table, and then the alter table by Bob, and then finally by DBO. The name of the object, that got touched here, and then the actual T-SQL, which is probably the most interesting. Trying to show more of that here. That made the change here. So having seen that, let's go look at some of the code that's behind all this. Okay, so the main work here is being done by this control check trigger. It's actually triggering for all these various DDL events, for alter proc, drop proc, function, table, view. I could specify any number of DDL statements here. And I'm also showing the use of XML here. The event data built-in I mentioned, it's actually returning XML values. So XML is actually great for the scenario because different DDL statements generate different kinds of data. In the case of DDL on a given table, it gives table-specific information such as the columns that are getting added and so on. Say I want to create a DDL trigger for a login event or a create login statement. In that case, the kind of information that's there is completely different. So XML is actually a good way to denote the kind of information that's for each of these different classes of DDL statements. So I get the event data information, store it away in this XML variable called addData, and then I issue a couple of X queries against that variable. So I go to addData, execute an X query that gets the name of the object and the name of the schema. So this is how I retrieve what object is being touched by the DDL statement. Once I have that, then it becomes straightforward. I go check in the checkouts table whether there is already an entry there for that given object and given schema. And if so, then the corresponding user better be the current user. If it is not, then you say that that user has that object checked out. If there is no entry in the checkouts table, then you basically say you check out the object first. So in both cases, notice that you are doing a rollback that basically denies the original operation itself. I have the second trigger here, which records all the version information. So all I'm doing here is inserting into the object versions table, and I am extracting from this event data the various pieces of information I want, the event type, the schema, the object, and the T-SQL command itself. And I'm populating this into my object versions table. So that's pretty much how that works. Okay, let's move on to the next feature on the procedural transact SQL space. Transaction abort handling. This is a very commonly requested feature where people like better exception handling capabilities in transact SQL. Today, you do that by specifically looking at the add error code after almost every statement. So we addressed this partially in this release. We unfortunately didn't go all the way, and we now allow you to catch transaction abort errors. We don't support all kinds of statement abort errors, but there is a large class of errors that abort the batch and abort the transaction. So the scenarios here, there are quite a few scenarios. First of all, you may want to just simplify your code where you do all your exception handling in one place inside your stored procedure. And also there are cases where you don't even get control within that stored procedure because the transaction abort transfers the control to the client, which means that you're not able to do any kind of exception handling inside your stored procedure. For example, you may want to log some state whenever errors fatal to the transaction occur. You also may want to explicitly abort a transaction, and so we have the extension to the raise error statement where you explicitly doom a transaction. So let me describe what I mean by dooming a transaction. So basically, you have a try-catch block, just like you're used to try-catch blocks in traditional procedural languages like C#, C++, and so on. where whenever a transaction abort error occurs, control automatically shifts to the catch block. Now, the key thing here is that the transaction remains in doomed state until explicitly rolled back. So the transaction is not yet rolled back, because we still keep the transaction in that state so that you can get some useful information about what the error was, because if we roll back the transaction, you lose the error code as well. However, when you are in this doomed state, you cannot actually do any writes, because you need a transaction in order to do a write operation. But you could do reads on the database. You could send a message to the client. You could return a value as a result of the stored procedure, and so on. And you can still query the @error system variable as the very first statement in the catch block, because after the first statement in the catch block, @error is going to be reset, so you need to do that in the very first statement. Also, any point inside your try block, you can explicitly raise the exception, which is a transaction abort exception, which will allow you to transfer control to the catch block. So I have an example of a typical usage of this transaction abort handling feature. So let's say you have a very simple stored procedure that does some DML in a table. So let's say this is how it looks today. I start a transaction, I commit it, I do some DML inside the transaction. Now, if there was any constraint violation that aborted that transaction, what happens without exception handling is that the control, basically this whole procedure aborts and the control goes back to the client. So you cannot do any kind of logging or any other kind of exception handling inside that stored procedure if you want to do that. So how you would do that using the new feature is to encapsulate that logic in a try block and have a corresponding catch block which does your exception handling. So now basically when a transaction abort occurs here, control is transferred here, and the first statement you do here is a rollback to roll back the transaction which is now in a doomed state. Now once you roll back, you are in a new transaction, and in that transaction you can actually you can do some logging of that error. So in this case, I chose to log the values that caused that transaction abort. And then in this case, I also chose to do an explicit raise error with transaction abort, which basically preserves what the stored procedure was doing before. So originally the stored procedure was going back to the client with a transaction abort error. Now the same thing happens, except I've introduced some logging in the middle of that. Okay, finally, let's talk about statement level recompile. This is primarily a performance feature. This is introducing no surface area in the product. It's something that you take advantage of as you just use Yukon. As you might be familiar, in SQL Server 2000, compilation happens at a module level, be it as stored procedures, triggers, functions, or batches. In Yukon, the compilation model still remains the same. It's still a module level compilation. But recompilation now happens at a statement level. So often you may have issues that you have encountered in your applications where recompilations are actually costing performance. This happens at times with usage of temp tables, sometimes because of recompiles created by, caused by statistics changes. So you may have a big stored procedure where right in the middle of the stored procedure, you have a query on which we have sensed that the statistics are out of date, and we trigger a recompile. Now the recompile is actually going to recompile the entire stored procedure. So you have a stored procedure with 1,000 statements, and in order to just get the new stats for that one statement, we have to go and recompile the whole stored procedure. So with the statement level recompile feature, we don't have to do that. We now recompile just that individual statement and keep going. So what's the implication of all that? Recompilations cost less. You're not recompiling the entire stored procedure. You're just recompiling an individual statement. It also, interestingly enough, causes fewer recompilations. The reason being, in addition to the stored procedure level plans that we are caching inside, we are also caching the statement level plans in our plan cache. So often we have to recompile because some set option changed. Let's say you execute a stored procedure the first time with one set of set options and the next time with another set of set options. And because we now have individual statements cached with individual set options, we may not have to do that. We can reuse those individual statement plans again. So obviously the scenarios that benefit most are recompiles caused by statistic changes. That's again a common case of why recompiles happen. Another reason why recompiles happen is because of the usage of temp tables. So if you have a temp table and then use that temp table multiple times inside that stored procedure that created that temp table, you're going to see recompiles today for every usage of the temp table after that first time it got created. Now that's going to benefit because now you're not recompiling the entire stored procedure again and again, but you're just recompiling that individual statement. Debugging. So how many of you have used T-SQL debugging? Exactly. So the big change with Yukon is T-SQL debugging works out of the box. We don't have, unfortunately, that enabled in the bits that you will get in the PDC. It does work with Visual Studio Whidbey. In Beta 2, we will have that enabled through the SQL Workbench as well. You don't have to go through the configuration steps that you might have gone through in order to get T-SQL debugging work in SQL 2000. We also are enabling debugging cross-tier from a SQL client to SQL Server using Visual Studio Whidbey. So let's say you are in Visual Studio Whidbey debugging a client application that connects to SQL Server, executes a stored proc. Now we don't have directly stepping in from the client into the server, but what we do support is the ability to set a breakpoint in your stored procedure, and if your client app hits that stored procedure, it will stop at that point. We also have seamless cross-language debugging between T-SQL and managed. So now that we have support for managed languages inside the server, you may have T-SQL stored procedures calling managed stored procedures and vice versa. And we support seamless debugging across those two language environments. So you might be able to, you can basically step in from a T-SQL proc into a CLR proc and vice versa. Okay, so I have covered a lot of features today, but I really could not do justice to all the features that we are doing in Yukon. So this is just a laundry list of things that I'm not covering today, but I just want to briefly mention. We have new catalog views. These are the official metadata interface going forward from SQL Server Yukon. So today you may be using system tables, which are still supported. We are fully backward compatible. We will support those system tables. But we do have these new set of catalog views that are read-only. They're not updatable, even through this configure option that allows you to update system tables. And they all live in the new schema called sys. So we have this new system schema called sys, in which we have a whole bunch of new catalog views. Another big change that's happening in the system catalog is a permission-based catalog visibility. So today, everybody gets access. If they are a user in the database, they can see all of the metadata inside the database. Whereas with the Yukon model, you need to have some level of permission to see metadata on that object. So let's say you don't have any permission on a table, then you'll not be able to see metadata on that table. We do have a mechanism to override that, where you can specifically grant metadata permission to a given user. So if you are concerned about backward compatibility, there is a fairly simple way to get that full compatibility. But really, we believe the right model here for catalog visibility is that only users who have some permission on that object should see metadata on that object. Other things on the security space, we have execute as support for procedures and functions. This enables executing a procedure as the owner as opposed to the caller, which is the model today. This also allows you to handle one of the issues today with ownership chaining. So we have this ownership chaining model where if the owner of the proc is the same as the owner of the table that proc is calling, we don't check permissions. So it's kind of, you can think of it as a poor man's ownership, execute as owner. But that doesn't really work if you're doing dynamic SQL. Let's say you did an exec string in your stored procedure. You may have run into this problem where we don't honor ownership chaining. Actually, there are good security reasons for that because it actually protects you from SQL injection attacks. You may have an exec string which is constructed based on some parameters, and the parameters may be doing something malicious that you didn't intend to inside that stored proc. Execute as allows you to do this, run as owner, even for dynamically constructed SQL strings. Of course, if you use that, you have to be careful in validating any parameters that you get in, because if you enable dynamic SQL through execute as, you may run into security issues. Also, I want to mention the new performance tuning tools that we have in the product. We have a whole new set of virtual tables. These are tables that get constructed in memory that allow you to debug, troubleshoot, and profile various applications. I just want to mention sys.request_stats. That's interesting because it allows you to look at the top n queries that against your database that are consuming the maximum number of resources, be it memory or CPU and so on. So we have this virtual table that tracks statistics of the costs consumed by various queries that are running against your application. So I would like you to take a look at these various new virtual tables that are available in Beta 1. Okay, so to the million-dollar question, T-SQL versus .NET Framework. So when do I use what? So if you attended the managed code in Yukon talk yesterday, they went into this as well, and I want to repeat that here. T-SQL remains the best language if you're doing data access. Predominant data access scenarios still should use T-SQL. Note that even if you're using managed code, you are going through T-SQL. You are either calling functions from your T-SQL queries, which are written and managed, or even if you're writing a managed stored procedure, you're doing DML operations on queries using T-SQL statements. The query processor is great for declarative set-based access. It's very expressive and compact, and it's also very efficient. Also, the T-SQL data access model is more of a static model. If you write a T-SQL procedure, you have static SQL that's embedded inside that stored procedure, as opposed to a dynamic model which the managed programming model uses. What is the .NET framework great for? It's for server extensibility. You can extend the set of built-in functions that we support, data types that we support, and aggregates we support using user-defined functions, types, and aggregates. So the managed programming in SQL Server talk went over all of that. In fact, I hear there's a repeat of that talk on Thursday as well, in case you missed it the first time around. .NET Framework is great for business logic and computation with little or no data access. So the strength there is the use of .NET Framework API. So things that you find extremely hard to do in T-SQL sometimes are extremely easy to do using the .NET Framework with the rich set of APIs that is available as part of the .NET Framework. You can also leverage the symmetry with the mid-tier programming model. So the mid-tier programming model uses ADO.NET, which is exactly what you use if you write managed procs inside the server. And finally, I want to stress that you can leverage strengths of both these models. You can use T-SQL, which calls managed functions, for example. To conclude my talk, so I want to show you T-SQL is alive and kicking. This is also my call to action slide. Use T-SQL and .NET Framework judiciously based on the design guidelines that we just proposed. And again, the key thing I want to stress is take advantage of the new query language enhancements. use the expressive power and the performance characteristics of the query processor. And finally, take advantage of the new and improved development experience that we are enabling with better debugging, better integration with tools, and better support for troubleshooting and perf tuning and applications. So these are some additional resources that you can go take a look at. If you have questions on Yukon, you can come and talk with us. We have the Ask the Experts Lounge near room 309. We have this forum in SQLjunkies.com where you can post questions and get them answered. We also have a whole bunch of websites here that have additional information. So with that, I conclude my talk. Thank you. If you please come to the mic.
Question.
Yeah.
In the part where you were using the contains with the new full text search with multiple columns, is that and logic or logic? In which case, does this column and this column contain that? So it's and logic.
I believe it's or.
Is it or?
Yeah.
And I asked that because I did some ors where I had to do a single contains on each one, and ended up with a Cartesian product across 4 of these things. So instead of getting 50 rows back, I was getting 8 million rows back, and that was not a good thing.
Okay. So you were expecting and?
No, I didn't know.
Okay.
You just didn't say.
Okay.
How would the performance of the new recursive query thing compare to something like a dedicated hierarchy table?
If you mean by a dedicated hierarchy table, something that just handles a fixed number of levels?
No, I mean something that handles an arbitrary number of levels, but contains a record for each pair. So for a 5-level tree, there'd be 5 entries for each element.
I see. The question is, how would the recursive query compare in performance with a case where you have the hierarchy duplicated basically for every level? I would suppose that would probably perform better, though I don't have any data backing that up. But clearly you have a lot of data duplication, and size of data really increases, especially if you have large numbers of levels. So yeah, so it has pros and cons, that approach. Thanks.
Yes, I had a question regarding the CTEs.
Mm-hmm.
I wanted to know if we could see a CTE and a query plan of a CTE and see how it's represented.
I don't have that written up as a demo. We can probably talk offline about it.
Okay.
If you come to the lounge, and I'll try and show you.
I'll pass because I had a similar question. You have a SQL data type called table, right? You can declare a variable of type table.
Uh-huh.
So how is that different from the CTEs?
The table variable is more like it's really implemented using a temp table internally, except
stored in the DB temp table.
Yes, but so with CTEs, you are really you're building this result set and losing it after that query. It's just used within that single query. If you really want a temp table or a table result set that you want to work with across multiple SQL statements, then you really need to use a table variable or a temp table. In this case, it's a temporary result set, the scope of which is a single select statement. If you really want to use it across multiple statements, you need to continue to use a table variable or a temp table. And by the way, the table variables have been enhanced somewhat in Yukon with some of the restrictions that you had in SQL 2000 now addressed, like support of user-defined data types inside table variables and so on.
Also, in user-defined functions, previously until SQL 2000, you couldn't create like temporary tables. So can we create CTEs inside user-defined tables?
That's right. You should be able to call CTEs inside a UDF.
My question is also in regards to common table expressions. How is it more powerful than me creating a temp table and creating indexes on it? Are we planning to support indexes on common table expressions and use it within my query?
So if your table that the CTE is going against has indexes, the with statement will use it.
Okay.
There is no index on CTE itself because it's not a persisted object. It's just
Okay.
It's
So
just
in
a-
that situation, I'm better off creating a temp table and then putting indexes on the temp table and use it all over my query. You said that's a lot more powerful, right?
You could create those same indexes on the table itself, unless for some reason if you're generating new columns
Yeah.
on which you want to create indexes, then yeah, you'll. If that's important in your original scenario, maybe in that case you want to continue to use temp tables.
Are we planning to include this functionality sometime in the future, or is it like a feedback that?
So you are asking basically for indexes on CTEs.
That is right.
Okay. I'll take that feedback.
Okay. All right.
I don't have. We can discuss this offline, but I'm not quite sure how this feature would work the way you would propose it.
All right. Thank you.
Yeah.
Is the row limit in Yukon still 8K?
That's a good question. To tell you the truth, I don't know for sure. There was some talk about enhancing that limit, but I don't know the final resolution on that. If you stop by the lounge or if you ask some other person today at the Ask the Experts, they might be able to answer you.
One more question about this varchar max.
Uh-huh.
Can you have more than one in a table?
Sure.
And it doesn't matter where it is in the table? It doesn't have to be at the end?
No, it doesn't have to be.
Related to the ranking functions, what about other SQL 99 OLAP functions?
They're not in the plan for the Yukon release. It's something that we are considering for the future, though. Which, may I ask, any specific ones that you're interested in that is missing?
The regular aggregates
Okay.
to support as analytic functions.
We do plan to support some of the aggregates, though I don't have the actual list on top of my head.
Okay.
In the current version of T-SQL, you have very limited support for regular expression in light clause, and also maybe in the full text search. Is there any change in the new version?
We don't have native support for regular expressions, but I would argue that is a classic scenario where you want to use a managed function. So the .NET framework happens to have a regular expression class. I think it's called system.regularExpressions or some such, which, pardon? Yeah, system.math.regex, which pretty much has a lot of the regular expression functionality. So pretty much all you have to do is to create a wrapper around that and deploy that as a user-defined function.
Also, in the query analyzer text editor, do you support the regular expression?
I'm not sure what you mean by supporting regular expression.
In the text editor, right? In the Visual Studio, when you do search or replace, you can
I see.
regular expression. In the query analyzer, do you support that kind of thing?
I don't know the answer to that question. You might have noticed that the SQL Workbench has now the look and feel of Visual Studio itself. So it's using the underlying IDE technology now. So if that facility is available in Visual Studio text editor, the good thing about this is now you will get that feature in Query Workbench as well.
How about column editing?
What do you mean by column editing?
Or you add by column instead of row, sometimes.
I'm not sure. I'm not the expert on the tools, but if you stop by the SQL Server desk at the Ask the Experts, somebody there will be able to help you.
So are you saying that the regular expression is going to be optimized in that managed function against the query plan? Or is it just going to do a table scan and apply the regular expression?
So if you're doing a regular expression as a user-defined function, what you're doing is really passing the values from a column as an argument to the function. Yes, we will not have the same level of native support that we have for cardinality estimates by default, but there are ways to get around that. One is we have the ability to create indexes on computed columns, which is possible today with SQL 2000. Now you can actually create a regular expression function and create an index on that computed expression. And we now have stats on that column, and we can actually use the index. So we could actually evaluate it and persist it in the index, and we don't have to recompute it.
Okay, and if I use if I create a common table expression and do a select with the common table expression as a column, as well as in the where clause, is the query plan for that going to be to run that once and use the value for both uses, for both in the where clause and in the for example, let's say I'm doing a select and then a subselect with a count on another table, and I'm saying where the count on the other, where the count is greater than some value.
So you're talking about the select that uses the CTE versus the CTE itself?
Right.
They all work as a single statement. So there is a plan that captures both of them.
But is the common table expression run once, or is it run twice since it appears twice?
It is run only once. So in that sense, you're not gaining any more from what we do today. So even today, if you have a common table expression inside your query, which didn't use this with CTE, we try to identify common expressions and evaluate it only once, and that will continue to happen with CTEs as well.
And then finally, what's the purpose of the apply operator? Couldn't you just say outer join table returning function and give it parameters that are columns instead of?
We could have done it that way. We just chose to have a separate syntax because outer join is really meant for two tables that already exist, whereas with outer apply or cross apply, you are really generating one of the inputs based on the other input. It's not a pre-existing table.
Okay.
Do you know if there's going to be any effort to implement intersect or mine as a corollary to union?
That's a good question. That feature got cut from Yukon, but that's something that we will consider for the future.
I know we see it a lot in the news groups. A lot of people ask for it.
Yeah. I'll note that down as feedback.
Thanks.
I have a couple of questions. Can you hear me? One concerns table variables and a restriction in 2000 that would not allow us to insert a result set generated by the stored proc into a table variable, but you could insert it into a temp table. The distinction, silly me, I don't understand why you can do it with one and not the other one. We were trying to standardize on getting rid of old-style temp tables and doing everything by table variables, but we had this one case where the output of a stored proc needed to go somewhere and we couldn't use the table variable. Have you fixed that?
Unfortunately, I don't think so, but that's something I'll look into. That might be small enough that...
what's the difference?
So may I ask why you are moving away from temp tables and using tables?
Table variables are better scoped.
And you probably run into less recompilations with table variables.
And
documentation says table variables are the way to go, and they are 3-4 times faster than treating temp tables.
you got to be a little creative about indices on them, but by creating unique constraints, you can
address some of those.
You can make any index you like. You just have to arbitrarily stick the primary key at the end of the unique constraint to create additional ones to make it work. It works very well. I really love table variables. The other one was to do with user-defined functions. In 2000, a UDF must always be deterministic. And there are cases where I would like to create my own non-deterministic functions, and you're simply not allowed to. Can you do that in Yukon, either A, with T-SQL-based user-defined functions, or B, with .NET-based ones?
Yeah, we will relax some of those restrictions in Yukon. In managed, you can pretty much call.
You can do anything you
You
like.
can do anything you want. And in fact, we now rely on the user to tell us whether it's deterministic or not.
Well, in 2000, you simply weren't allowed to be non-deterministic.
That's right.
And therefore, you
Well,
couldn't do simple things like calling getDate
That's right.
inside a UDF. And I ended up having to create UDFs that took as a parameter a date that was always passed in via getDate on on the select statement just to have the current date context applied to the UDF, right? Which kind
Yeah,
of
there are
silly
some
thing to do.
there are some interesting semantics issues as to how often you evaluate it. Do you evaluate it per row or not? Which is one of the reasons why we prevented that from happening. But I know for sure you'll be able to do that from managed. We are still debating whether we want to remove that restriction on T-SQL or not. But yeah, I think we should do that.
I think so. I'd appreciate a final answer on the table variable one, because that one was an annoyance to us in the last project we've done.
Okay, I'll take that feedback. Thanks.
Just one more quick question. Currently in 2000, when we have a for XML clause, we can't have a for XML clause in a subquery. When you have,
Yeah.
is that something that we can do in Yukon?
I'm not sure about that. You should talk to some of the XML experts. You might want to ask that question to the XML presenters tomorrow morning. I believe it is fixed, but I'm not sure.
I heard a rumor that you'd be able to pass a variable into a top statement. Is that true in Yukon?
Yes, that's right. So that's one of the features I couldn't get to cover in my talk. You'll be able to now parameterize your top with variables. Thank you. I forgot to make this announcement. Make sure to fill in the evaluations. Thanks.